Okay, so in this video, we're going to be talking about how to find the distance between 2 points. Now, in order to do this video, you do need to know how to do the Pythagorean theorem. If you do not know how to do the Pythagorean theorem, I will go ahead and link that video below. That way you have access to that content. But assuming you know how to do the Pythagorean theorem, let's get right into this video and talk about how we're going to find the distance between 2 points. So before I show you the formula that we're going to use, we're actually going to derive it. And that formula is going to be the distance formula. So what I have here is a coordinate grid, and you can see that I have 2 points in the first quadrant. Now, these 2 points could be anywhere, doesn't matter, but I just put 2 points in the first quadrant, and I labeled them x1, y1, and x2, y2. And we're going to use these 2 points as well as Pythagorean theorem to go ahead and derive the distance formula that we can then use to find the distance between any 2 points. So for example, if I start at my point here, x1, y1, and I draw a horizontal line going to my x2, y2, that's going to leave me with something like this here, okay? And then if I draw a vertical line going from this new point up to x2, y2, I'll have something like this here, okay? And then we know that we will eventually have a hypotenuse, right? Something like this here. Now, that hypotenuse is actually going to be our distance, and we're going to use that to derive the distance formula. And what we're going to do right now is use this right triangle to derive the distance formula. So for example, my hypotenuse, I'm going to call d for distance, okay? Now, this length right here, okay, and this length right here, I don't have an actual value, but I can represent it using variables, right? So for example, I know that going from this point right here to this point, I can say that's going to be x2 minus x1, right? So for example, this whole horizontal distance is going to be x2 minus x1, okay? And again, those x values could be anything, but that's how it's always going to work out if you're given 2 points, right? And then this vertical distance right here, well, I can represent that with y2 minus y1. Okay, so y2 minus y1. And again, the values are irrelevant here. Doesn't matter what my y2 is, my y1, this will always work out. And so now think about it. If I have a right triangle and I use Pythagorean theorem, I know that a squared plus b squared is equal to c squared. And so you can essentially call this whole part here a, this whole part right here b, and then d is essentially your c. So for example, what you can say here is a squared, or in other words, x2 minus x1 squared, right? Plus my b, which is y2 minus y1. So in parentheses, y2 minus y1, and then square it. This is going to be equal to c squared, or in other words, d squared, right? And so from here, if I want to solve for d, all I have to do is take the square root on both sides, and I'll have d equals. So for example, if I take the square root here, and I take the square root here, well, right here on the right-hand side, the square root will cancel out because of my exponent of 2. And you're going to be left with d is equal to the square root of x2 minus x1 squared, and then plus y2 minus y1 squared, okay? And that's going to be it. So that is going to be our distance formula. So again, these 2 points could be anything, but that's how I'm going to plug it in. I'm going to use x2, x1, and y2, y1, and then I'll be able to get the distance between any 2 points, all right? So this right here is the distance formula, right? We just derived it. So from here, I want to go ahead and apply it. So let's take a look at our first example. So here's our first example, and you can see that I have 2 points. Now, you don't have to go ahead and draw in the right triangle. There's no need, because we have already derived the distance formula. And so again, the distance formula is d is equal to the square root of, right? And then we have x2 minus x1 squared plus y2 minus y1 squared. So all I have to do is plug in these points, and I'll get my answer. Now, I'm going to call this point right here x1, y1. You could call it x2, y2. It doesn't matter. But what you don't want to do, don't say this is going to be x1 and then call this y value y2. That's going to be incorrect. You have to keep your 1s and 2s together, okay? So for example, if I call this x value x1, that means this y value has to be y1. And as a result, this will be x2, y2. All right, so now all we have to do is plug it in. So I'm going to say here d is equal to the square root of, my x2 is going to be 4. So I put 4, and then minus my x1, which is a -2. So the two negatives make a positive. So this becomes positive, and then I have 2, and then I square it, right? And then plus my y2, which is going to be -3, so -3, minus my y1, which is 4. So I put 4, and then square it. So then simplifying it down, we get d is equal to the square root of, this will give me 6 squared plus -7 squared. Okay, so from here, going a little bit further, we get d is equal to 36 plus 49, and that will give me the square root of 85. So I'm going to say here d is equal to the square root of 85. Now, this is not a perfect square, so I want to leave it as the square root of 85, okay? Now, you could use prime factorization, you could break it down, but you don't want to go ahead and plug square root of 85 into your calculator and then round that answer, because then you're going to be losing accuracy. Leaving your answer as a square root, if it's an imperfect square, is going to give you the most accuracy. But if you wanted to break it down, you could. So for example, using prime factorization, you could say the square root of 85. Breaking that down, two numbers when I multiply will give me 85. Well, I could do 5 and 17, okay? And well, these two numbers are prime. 5 is prime and 17 is prime. I can't break this down any further, and I don't have any pairs. So I can't even simplify it down. This is going to be my final answer right here. D is equal to the square root of 85. All right? So that is the distance between these 2 points. All right, let's try one more example. So here's our next example. And on this one, I'm not going to write the distance formula. Okay, we're just going to go for it. So I'm going to call this point here x1, y1, and I'll call this point here x2, y2. All right. So plugging it in, we get d is equal to the square root of, so our first value here is going to be x2. So I have to do x2, which is going to be 4, and then minus my x1, which is -3. The two negatives make a positive, so plus 3, and then square it. Then I have plus my y2, which is going to be -5, and then minus my y1, which is -1. Again, the two negatives make a positive, so it becomes +1, and then squared. So now I have d is equal to the square root of, I'll have 7 squared plus -4 squared. And going a little bit further here, I get d is equal to the square root of 49 plus 16. Now when you add that up, you get 65. So d is equal to the square root of 65. And we know that this is not going to be a perfect square, but can we break it down? Let's try to use prime factorization. So if I do the square root of 65, can I break that down? Two numbers when I multiply, that will give me 65. That's going to be 5 and 13. So 5 and 13. 5 is prime, 13 is prime. I cannot break this thing down. I don't have any pairs that I can take out. So again, I'm going to leave it as the square root of 65. All right. So that is going to be the distance here between these 2 points. All right. So that is how you can use the distance formula. It's pretty straightforward. Now you know where it comes from. We derived it. It's essentially coming from a right triangle. And the distance is essentially going to be the hypotenuse of that right triangle. Again, we did derive that at the beginning of the video. So hopefully that did give you more of a visualization as to what's going on here and where it comes from and how you can use it. So if the video helped you in any way, or if you gained anything from the video, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.